We define the nth root of x is defined as follow, depending on n. Okay, if n is odd, okay, n odd, in the case n odd, then we define um, the number x1 over n. Okay, the nth root of x is defined like we can say this number is defined as y if and only if how x is our y power n. Okay, so and there is no restriction on x. Okay, for any x, this is true for any x in R. Now, for when n is even, so still we can write y and root of x here is defined is on yes only is we can write this quantity for with the same interpretation. Okay, when can we say that y is the alien root of x if we can satisfy this, but it's only for x positive or equal 0. Otherwise, it's not defined for x negative. Now radical. Um, so there's our radical exponents. So more generally, so we have here. Yes, we use also the notation radical like that. And yeah, for x we denote it. It's also x1 over n. Okay. And now we extend this notation for x power, fractional power. Okay. So which is also and then we can use the notation xm. Okay. So how we deduce it is we define 1 over x NDM root of x depending on the situation and take it to the power. Okay, so this is, and of course all there's powers with fractions obey the same rules of power, law of powers we saw for integers. Okay, we know for integers. In particular, for example, x minus m over n will be 1 over x power m over n. Okay, so mainly this is yes what you need to know. Be careful only on the parity of n. If it's odd, the n-th root is defined for any real number, while for when n is even, it's defined only for x positive. Okay, so let's practice as usual, uh, manipulating this kind of powers, okay, radical powers, we call them also. Okay, so for example, simplify. If we are asked to simplify the writing of our expression, I want to through details here. Suppose they give me x 11 root of x power 19. Okay, so by definition, I can see that I want to write it as power only, so it will be x 19 over 11. Okay, what about if they give me, if I'm given t power 1 over 4 times t power minus 8. Again, I have square root of t, t power minus n of an integer. I know the operations are the same as I can add the powers. Okay, I add the powers and reduce, do my calculation between the those numbers. So I have 1 minus 32 minus 32 over 4, which is t power minus 31 over 4. Yes, what if I am asked to simplify this expression minus 3, yes, y times power minus 1 times 4 times y minus 4 over 3. Again, here I see I have numbers and they have one variable y with powers. Um, inside it parentheses, everything is written, so it's simplified. But if globally I want to simplify my expression, I can do it. I can do it by regrouping the numbers. For example, I will say minus 3 times 4 and regroup the powers. Okay, times y minus 4 over 3. And here then I use minus 12 operations. Then here I can add the powers. Okay, y minus 1 minus 4 over 3. I reduced same denominator and get my final answer, minus 3 minus 4 minus 7 over 3. Okay. Now, um, now look at another kind of question. Suppose that they are asking me to eliminate the negative power. Eliminate eliminate the negative power. Mm. Okay, so here it is. X power minus, so it's here is I'm given minus x power 1 over 9, um, y power 1 over 8, z minus 1 over 3, and everything to the power of 48. Yeah. Again, many ways you can start, different ways to decide what is best for you. Okay. So for me, I can say I will take x1 power 9, everything separate, 48 over y power 1 over 8, z minus 1 over 3 power everything. I separate the power, numerator, denominator. Then work separately. So here I have minus 1 to the power 48 and x 1 over 9, power, everything power 48. Divided here, y power 1 over 8, everything power 48. Okay. And here z minus, remember, so the rule I am using here. So maybe I can write it, try write it here. So we use it here, the rule EB. We use it EB, power, everything power n. N is can be a fraction, so it's en bn. This is what we are using here. Okay, let's continue. So minus 1, I know I have a minus, let's do it here, 48. It's minus 1. I can write 2 times 24. I can write it minus 1 square, everything, 48. Sorry, 24. Okay, so that when you multiply, you get exactly the expression. So it will be a minus 1 to power 2, minus 1 times minus 1 is 1. So 1 power 24, which is 1. Okay, so that's why here I can simplify and say I have 1 here. Then here I multiply also. We use a power n, everything power m is a power n times m. Okay, for this one and the other terms also. So we will have x 1 over 48 over 9. Here y 48 over 8 and z minus 48 over 3, which gives me x 48, leave it, it's positive power. This one is a positive power, 6. And here minus 4, it's 16, z minus 16. Then I use, so let's write here, well, number 24, power 24. Here I'm using the fact that 1 over a power minus n is a power n. So this is what I'm using. So it will be z, um, sorry, x power 48 over 9 times z 16 over y power 6. And here I have my simplified expression since I have only positive powers and only three expression each with different variables. So yes. So this is how we do it here. We did it here. Okay, by reminding these rules we saw previously. Okay.